2023, question 7. With this molecule, the longest carbon chain is propane, which contains 3 carbons, and we have 2 methyl groups. As there is no other choice, so we can forget about the position. So the molecule is dimethylpropane. So if we compare both X and Y, well, that is the alkane versus alkene, because molecule Y contains CC double bond, which is an alkene. The burning characteristic will be Y will burn with more sooty or yellow flame. So you can see this is a comparison, more sooty or more yellow flame. Don't forget to mention this in your answer, because molecule Y contains higher carbon to hydrogen ratio, or you may say it got higher percentage by mass of carbon. What about the chemical test? This is typical. First, you add bromine in organic solvent to both X and Y separately. The orange-brown solution decolorize quickly in Y but slowly or no observable change in X. Or you may use acidified potassium permanganate. This time, the violet solution decolorize in Y but no observable change in X. 2020, question 8. The process mentioned in question is how to change crude oil into alkene and finally 1,2-dibromylethane. So let's focus on the first step. Started from crude oil, different fractions will be separated by fractional distillation, and those heavy fractions like diesel or heavy oil or fuel oil will be further cracked into alkene. So you can see the keyword. The first one is fractional distillation. The next step is crack the heavy fractions like heavy oil to ethene, which is an alkene. And here we include a chemical equations. Next, after cracking, we have a lot of product in the mixture. So we need to carry fractional distillation again to obtain ethene for the further process. And here you can see how the marks are allocated in the first step. The second step, how to change ethene into 1,2-dibromylethane. So we must use bromine in organic solvent through addition reaction. So here shows the keyword. And don't forget to include a chemical equation as mentioned from the questions. 2015, question 6. With the formation of radicals, sure, this is a substitution reaction. Reaction condition is simple. Sunlight or UV or even heat can start the reaction. And the expected observations is also typical, because this time we use bromine. So the orange-brown solution will fade or decolorize or change to colorless slowly. So you can see I include both color and the speed. Next one, why the radical is so reactive? So many of you write down because it don't have shared electron or one unshared electron or unpaired electron. This is correct, but not enough. The question is, why with one unpaired electron is so reactive? So let's back to the basic answer is because the radical doesn't have octet structure. The reaction will not stop here, so further substitution undergoes to form dibromomethane, tribromomethane, or even tetrabromomethane. So how to guarantee the monosubstitute one is the major product is we use excess methane or limited bromine solution